So what we're going to do, I'm going to go over notes 8.2. The reason why I'm going to go over that before you take your quiz is for us to review your shapes. Not your shapes, your Lewis structures to make sure we're good on those. So, what page are your, do your notes 8.2 start on? 69. So if everyone will turn. All right, so we're not going to talk. I'm just now starting to get my voice back, sort of. So I can't shout over you or else I'm going to lose it again. So I'm at the bottom of page 69 on number 1, CO, carbon monoxide. All right, so remember your rules. What's the first thing I need to do in order to draw my Lewis structure? Count my number of electrons. So for CO, I counted 10 valence electrons. Are we okay with that? Awesome. Okay, so I have 10 valence electrons. What's my next step? CS, share. Okay, I shouldn't only hear Connor and Jenny. Share. L is lone pairs of electrons. Remember, everyone wants how many valence electrons? 8 except for hydrogen, which wants 2. Fantastic. So if I were going to share, or not share, if I were going to do lone electrons, it would look like that, correct? What's my last step? Count again. 2, 4, 6, 8, 10, 12, 14. I need 10. And I required 14 to draw this. So that now tells me I'm going to need what?
Double bond.
I'm going to need a double bond. So I'm going to get rid of these 2 because I'm going to share 2 instead. But if you do that, I'm using 12.
So it's a triple bond.
So it's a triple bond. And that is your answer. Are you okay with that?
Yes.
All right. SeO2. I'm going to first count my total number of electrons that I need, my valence electrons. How many did you get? 18. Okay, now I'm going to share. Then I'm going to do my lone electrons. I'm going to make sure everyone has 8. So oxygen needs 6. Selenium already has 2. Now it has 8. 2, 8. Are we okay with that for right now?
Yeah.
Okay, let's count. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. No, I am not okay with that. Therefore, I'm going to need a double bond. So I don't know where to put that double bond. So I'm going to just put it on the left-hand side. I'm now using 18. 2, 4, 6, 8, 10, 12, 14, 16, 18. But if you were to make this, that shape is incorrect, and I would take off half a point on your quiz. You need to make sure to show this properly, showing that the shape itself is bent. Looks like that. Do we agree with that?
Yeah.
What am I missing though?
The other.
A second one, right? Because this is a case of resonance. So I need my double bonds either on my left-hand side, or I need to draw the other version where it is on my right. Are we okay with that? Yeah, Connor.
I have a question. What's the difference between bonded atoms and lone pairs?
Bonded, there's a bond. Lone pair of electrons. There's another hand. CC.
Oh, so is it every time there's a double bond you have to do the?
If you have one spot that has a double and one spot that has a single, almost always. Yes. Rachel. If it didn't have a lone pair, absolutely it would be linear. That would be straight line across. Yep. Other hands? Okay. Let's do some more practice. So I'm on the next page. Okay. Let's look at chlorine. How many valence electrons will chlorine have? 14, awesome. So I'm now going to share electrons. Lone pairs to make everyone happy. Now I'm going to count it again. 2, 4, 6, 8, 10, 12, 14. I am good. Okay, I can be done with that one. CBR4, I should be using how many valence electrons?
Six, four, no four.
I'm not going to yet, because that's the next lesson. CBR4, how many valence electrons? 32. Using my model kit, I know that it should look like this. You guys okay with that drawing? Okay. And if you count, I'm using 32. Any questions for 1 or 2? Okay. CH3Cl requires 7, 10, 14. Okay. I'm using 14 right there. That Cl can go wherever you want though. It can be on top, it can be on the left, the middle, or the right. It doesn't matter. Because if you look at this, okay, imagine this is the compound, right? So I've got chlorine, hydrogen, hydrogen, hydrogen. If I flip it like that, I would have hydrogen on top, hydrogen, hydrogen on either side, and then the chlorine would be on bottom. Or if you had it like this, it would be the chlorine here, and then hydrogen, hydrogen. It doesn't matter, because you're just literally just bringing it around. So where you put the chlorine doesn't matter. Are we okay? All right. Last two. CH2O. How many valence electrons do I need? I believe 12. So the structure would look like this. Sorry, I don't want to. So I'd have hydrogen coming down, oxygen. So if I did that, this would require 14 valence electrons. 2, 4, 6, 8, 10, 12, 14. That's incorrect because I need double bond because I need 12. And the last one is pH3. I should use a total of 8 valence electrons. So this is what it ends up looking like. Keep in mind, guys, the shape does matter. If you draw this like this, if you drew pH3 like that, I would take off half a point. That is not the shape. That's not how it exists. It exists like this. And when we get to talking about polar versus nonpolar molecules, which is today, it will really affect whether or not you think it's polar or nonpolar. So it's not just me being OCD. You really need to know. Okay. Any other questions about Lewis structures, process of doing it, anything that's unclear? Are we okay? Okay. You guys have your quiz right now. When you're done, I need you guys to wake up because today, not like wake up to life, like actually like physically wake up because today's gonna be pretty intense. Just letting you know. It's gonna feel like an honors class today. So if you're tired, you need to get over it. You need to sit up and or if you want to use the bathroom when you're done with your quiz, splash water in your face, wake up, you have some energy. Because otherwise it'll go straight over your head and you'll fail your quiz next block. Just warning you. Okay? So make sure that you guys are ready to go. I need you guys really to focus, and as soon as something comes up that you don't understand, I need you to ask. Because I'm going to review the notes, but then there are going to be 2 new not truly new, but 2 new things that we do need to go over as well. So not only are we reviewing the new stuff, but I'm going to introduce 2 new things. Okay? So as soon as an issue arises, please let me know. All right. So there are a couple of terms we need to talk about. Okay? I like to call them bonding groups or bonding domains and lone pairs or non-bonding domains. So I often call these bonding domains. And these are non-bonding. So let's make sure we understand these terms so we can use them to determine shapes. All right, so did you make me my linear? No, like linear with 2 double bonds. Okay. Do you not have enough springs?
Yeah.
Can someone make me linear? Like up there? Sorry.
Someone give me a black ball, please.
All right. So if we look at linear here, someone will make it for in a second. But if you look up at linear right here, do you guys notice how there are two double bonds? And that's it. Okay, because if they're two double bonds, that means I'm not going to have any lone pairs on my central atom. So what I would say is I have two bonding domains, zero non-bonding, because I don't have any lone electrons on it. So I have a total of 2 electron domains. 2 are bonding, none are non-bonding. Are we okay with that term? Those terms? Did someone make it? You did? Okay. If you guys notice, there are no empty holes on the central atom, right? Because if you have 2 double bonds coming off of this central atom, it has 8 electrons. So it's going to look like this. You're going to have 2 bonding, 0 non-bonding, a total of 2 electron domains. Are we okay with that? Good? Yeah. Okay, let's look at the next shape. Trigonal planar. Rachel, there kindly made it for me. So if you look at this, I have a total of 3 electron domains. 1, 2, 3. 3 are bonding. 1, 2, 3, because they're attached to other atoms, right? You got 3 bonds. How many non-bonding? 0. Good. There are no lone electrons anywhere, right? Because if you look at this, I've got a total of 8 electrons around that central atom. So it's already happy. Okay? So this is 3 electron domains, 3 bonding, 0 non-bonding. Okay? So for these 2 different shapes, if it's linear, where did yours just go, Jenna? Oh, here it is. If it's linear, okay, what degree, what angle is this going to be? 180. Okay? So this is 180. We got that. Awesome. Okay? If it looks exactly like this, what's the bond angle going to be? 120, because you got 3 different angles here. 360 divided by 3 is 120. This shape is linear. This shape is trigonal planar. 3 bonding, 0 non-bonding. If instead it looks like this, okay, so you got 1 single bond, 1 double bond. How many total electron domains do I have?
2.
I don't. I have 1, 2, and there's an empty hole right there. So I have a lone pair of electrons. So it would look like this if I were to draw it. So it's 3 electron domains. I agree, 2 are bonding domains. 1 is non-bonding, meaning it's 1 lone pair of electrons. Okay? 2 bonding, 1 non-bonding, a total of 3. So if I asked, hey, what is the electron domain geometry, or the electron geometry, you would still say it's trigonal planar because it has 3 domains. But if I said, what's the actual geometry of it, it would be bent. Electron domain geometry of this is trigonal planar, and the geometry is trigonal planar because I got 3 atoms on it. This one, the electron, if I just looked at the electron, considered electron domains, it is trigonal planar, but the shape itself is bent. Yes?
Are we going to have this chart on a...
No. No. No, you will not. You'll get so much practice you won't need it. Okay? Here's the one thing I do need to change, and this is one of the new things that I'm teaching right now. This has a bond angle of 120 degrees. This, they said, has a bond angle of 120. They're wrong. The lone electrons at the top of this, they actually force the atoms, they push them down more than just a regular bond would. So as a result, the bond angle of this, it's kind of like that. It's not exactly 120. It's going to be less than 120. So while this is exactly 120, this one, because it has a lone pair on top, it's going to be less than 120. Do you need to memorize the exact value? No. Okay, 120, less than 120. Yes?
I'm a little confused for the second one, trigonal planar.
Yes.
Can you show where the 3 bonding are?
For this guy or this guy?
The
This one?
second, yeah.
This one, right?
No, the second.
For this one, where the 3 bonding?
Yeah.
1, 2, 3. They're 3 atoms. 3 bonding.
But then in the second one.
There are 2 bonding, 1, 2, and 1 non-bonding at the top. Are we okay? Questions? Because we got 3 more to go. Questions about the first 3. Okay. 2 electron domains. 2 bonding, 0 non-bonding. 180 degrees. Linear. Are we okay with that? It's a lot. I'm not saying this is easy. Are we okay with that? Is there anyone who doesn't understand the concept of the bonding versus non-bonding? Is that a hand? You don't have to be. Does that make sense to people? Because you're all nodding, and so I assume you do, and then I move on, and then okay. 3 electron domains, right? 3 bonding, 0 non-bonding, right? Because there are no lone pairs on this guy. Trigonal planar for electron domain geometry, and trigonal planar for the molecular geometry. Bond angle is 120. 3 electron domains, 1, 2, and a lone pair on top. 3, so it's trigonal planar for the electron domain geometry. It is bent for the molecular geometry because you don't have a third thing that you can actually visibly see. Its bond angle is going to be less than 120. Yes?
What about a diatomic element?
Most diatomic elements are just linear. So like if you have O2, right? When you just have 2, it's not even...
But does
Linear.
it change the amount of domains?
No, because this, you don't really have a central atom, so we don't really talk about the number of electron domains if you only have 2 elements.
So you just...
So you've skipped ahead, so I will tell you to NA it. Yeah, Melody. And then Sophia.
So for the bonding domains, is it always the same for like each shape, like 2 for linear, 3 for, and then but the lone pairs are always different.
So if you have 3 electron domains, the electron domain geometry will be trigonal planar.
Yeah.
But then since this one only has 2 bonding, it'll be bent. So that answer.
It's usually the same.
So the electron domain geometry is the same, but the molecular geometry, or the shape as they call it, will be different. Right? This one's trigonal planar because that's 3. This one's bent.
And then with the lone pairs is always different.
Yeah, this has 0 lone pairs. This has 1 lone pair. This is 3 bonding. This is 2 non-bonding. But the reason why they have the same electron domain geometry is because they have the same number of electron domains, 3. Okay? All right, who made me a tetrahedral? I don't know if you made it for me, but I'll take it. Okay, who made me a trigonal pyramidal? Thank you. And who made me a bent? Bronca. Thank you. Okay, so tetrahedral. Tetrahedral looks like this. 4 bonding. So I've got 4 things coming off of it, 4 atoms. Okay. 0 non-bonding. Agreed?
Yes.
Tetrahedral for both the electron domain geometry and the molecular geometry. We good? Okay. The bond angle 109. That's correct. Kind of boring. If instead of 4 atoms, I only have 3, keep in mind, if you look at the top, there's a hole. So you have 3 bonding, 1 non-bonding. So you still have a total of 4, but 3 plus 1 now. Okay, so that's how these two are different. This shape is going to be trigonal pyramidal because it stands up like a pyramid would. Okay, its bond angle is not 109. It's going to be less than 109. Uh-oh. Okay, the last one, if you look at this, notice I've got 2 empty holes. So I have a total of 4 electron domains. 2 are bonding. 1, 2 are non-bonding. So this shape is going to be bent. And its bond angle is going to be less than 109. Okay? Any questions about number of electron domains, electron domain geometry, shape, or bond angle? Are we okay?
Yes.
All right, I'm going to add something. Actually, no. We're going to go over the polar and nonpolar, and then I'm going to add something. All right. Let's look at page 71. All right. CL2, we had drawn it for your quiz. It looks like this. Oh, just as a review really quickly. How do I know if a molecule is polar or nonpolar? Okay, so if their dipoles cancel, is it polar or nonpolar? It's nonpolar if their dipoles cancel. If their dipoles do not cancel, it is polar. Another way to think about it, you can't explain it this way on a quiz or test, but another way to think about it, if the object does not move, it's going to be nonpolar, right? Because that means that all of the forces cancel each other out. Imagine like a huge tug of war. If the forces cancel out, it's nonpolar because your dipoles cancel. So let's look at this example. If I gave you this, Cl and Cl are going to be pulling on each other equally, correct? Because they're the same element. Okay, so is this molecule going to be polar or nonpolar?
Nonpolar.
Nonpolar. Good. Okay. If I draw CBr4, now for your homework, I had asked you guys to draw the dipoles. It was mostly just to help you. You never actually have to, I'm not going to make you draw them on a quiz or a test. If you want to draw them, awesome. If you don't, that's fine. Okay? But if I look at my periodic table, the reason why I don't require it, sometimes it's hard to know what's more electronegative. Just honestly, right? Because C versus Br, bromine's actually more electronegative. That's kind of weird. That's not what you would predict. Okay, so that's why I'm not going to be super strict about it. But imagine bromine's pulling up, this bromine's pulling down, down, down. Imagine these are, I don't know, horses or people or whatever. One's pulling up on carbon. These guys are pulling down. Would carbon move? No. Therefore, what is this molecule? Nonpolar. Okay. Why? Because the dipoles cancel. That's your explanation for it. Celia.
An element's more.
So remember, the great question, as you move across the periodic table, your electronegativity increases. As you move down, it decreases. But that does make it kind of hard because like carbon versus bromine, it's like, well, carbon is further to the left, so it should be less, but then it's higher up, so that's why it gets more complicated. Of course. CH3Cl, so I draw it like this. Okay. What did you guys say, polar or nonpolar? But hold on a second, this one was nonpolar. Why would this one be polar? You said nonpolar? Anyone else? I'm hearing a lot of polars. That's why I was asking. If this is nonpolar, why are you saying this is polar? Melody.
I'm not sure, but I'm just gonna guess.
Yeah. So chlorine is going to pull the electrons towards it. And hydrogen, either carbon's going to be more electronegative and it's going to pull this way, or even if you drew it incorrectly and drew it like this, because they're different elements, they're not going to be pulling with equal force. So as soon as you have different elements in a compound, it's very likely that it's no longer going to be nonpolar and it's going to make it polar. So this would be a polar molecule. Yeah?
So, the hydrogen is going to point to the carbon.
Yes, because carbon's more
So it's
electronegative.
like working with the chlorine.
Sure, if you want to think about that in those colloquial terms, yeah, that works. Yeah, gentlemen. Imagine like they're pushing carbon and chlorine's pulling carbon. Would carbon move? So it's polar. We okay? Sure. A lot of it's just sight and saying, okay, does it look like everything, all the dipoles cancel? It does? Okay, I'm good. And moving on. This is what we drew for number 4. Okay? Would this be polar or non-polar? Polar. What if all of these were oxygen? Then it would be non-polar because your dipoles would cancel. Because you got different elements, it's going to be polar. Got a sort of trick question. This was actually one of their questions from the AP directly. And I want you to think about it. I want you to quietly talk to your partners for, I'm going to give you 30 seconds to talk about it. Don't shout it out. Could I have resonance for number 4? Can I have resonance for that structure? Turn to your partner and talk about it.
I think, I don't know. Does the element matter? Like, if there are different elements, can there be a double bond to,
The fact that they're different elements is not the issue. Who's super confident with their answer? Celia.
Is it because hydrogen can only take 2?
Hydrogen can only have 2 valence electrons. It cannot form a double bond, therefore resonance is not possible. Congratulations, you got more points than most of my AP Chem kids did on that question because none of them got that. They all tried to do resonance with that. You can't do resonance. Hydrogen can only have 2 valence electrons. Okay? Congratulations. All right.
I'm just kidding.
Last one, pH 3 should look like this. Yes? Yes. No. Yes. Polar, non-polar? Polar. Fantastic. Okay? It might seem really stupid. Why should you decide polar, non-polar? Trust me, you're going to use it extensively in the next lesson. So it does matter making sure you're able to do that. Melody.
so you said, like if we had to explain this,
Yes.
you said, like what did you say?
Awesome. So if it's polar, what you would need to explain it would be to say that the dipoles do not cancel. That means it's polar. The dipoles do not cancel. If it's non-polar, then your explanation would be that the dipoles cancel. Does that terminology make sense though?
Yeah.
Okay, just want to make sure. They cancel each other out. You guys haven't gotten to, most of you haven't gotten to vectors in math, but the vectors cancel basically. The dipoles cancel, meaning it doesn't move. I got 2 last sort of challenging things to go over with you. They're not that bad. You ready? All right. I'm going to give you quick examples.
Because we're not partners, so I got it.
Right. I'm going back to CO. We drew it like this. Page 69. One question I will ask you on your worksheet. What is the bond order for this molecule? It sounds scary, I know. It really isn't. All bond order means is what is the value of your bond? Meaning, if I have a triple bond, what do you think my bond order is? If I have a triple bond, what does triple mean? 3. My bond order is 3. So my bond order for CO would be 3.
This is just a single.
Great question. Give me a sec. I'm getting there. What would the bond order be for this for this compound?
And 2.
It's 2 double bonds, right? So what would the bond order be? Each of them is worth what? 2. So my bond order for this is 2. I heard someone ask about, for example, if I give you this. What is the bond order for this compound? 1, right? Single. 1. So if I have a triple bond, the bond order is 3. If I have a double bond, the bond order is 2. If I have a single bond, the bond order is 1. That should be bringing up questions in your mind about what do you think? Yeah, Cece.
So, like, say the event one?
Like SEO2?
Yeah. Oh, what would that be?
Like this?
Yeah.
Great question. Is it clear whether it's a single or a double bond? No. Remember when I'd shown you resonance for this? I had said that what actually exists is just a mix of the two, right?
Yes.
So I actually want to average these bonds.
Oh,
So I have 1, 2, 3 bonds total, right? And divided by how many spots? 2. So the bond order would be 1.5. It's an average. 1 plus 2. Average of 1.5. I'm gonna like totally blow your minds. You guys ready? I want you to figure this out with your partner. Tell me the bond order of carbonate. Go for it. I'm just drawing all of them because you guys complained about resonance, and so I want to show you that I'm willing to do it too. Average. Huh?
Does it have to be a decimal?
It can totally be a decimal.
But does it always have to be?
No, we did single, we did bond order of 1, bond order of 2, bond order of 3. Yeah. I don't care.
Wait.
3.
But can it be a fraction?
Yeah. Fraction or decimal, however you want to leave it. Right, the 1.5 could have been 3 halves. Right? Alright, who feels they got it? Rachel, go for it. 1.33. Shh. 1.33. How did you do that?
There are 4 bonds, 3 spots, so we do 4 with
Absolutely. So there are 4. You have a total. If I were to average these, right? 1 plus 1 plus 2 is 4. Divided by, how many did I have? Well, I had a single, and a double. 3 spots. 4 divided by 3 is 1.33. So here's the question. This is AJ's question, which I give him full credit for. Why do I care? Why does this matter? Right? Here's why. Single, double, triple, right? Obviously, if it has a bond order of 1.33, it's going to be somewhere in between a single and a double bond, right? Okay. Which do you think is the strongest? A single bond, a double bond, or a triple bond? Triple bond is the strongest. Not only is a triple bond the strongest, it is also longest or the shortest. It's the shortest. Because it's not sharing 2 electrons, it's not sharing 4, it's sharing 6. Did I give you guys the nitrogen talk last class?
Yes.
Okay, right? So there's certain compounds that it's really, really, really easy to break them apart, right? For example, fluorine, chlorine, much easier to break apart than oxygen would be. One of the most difficult to actually break because it's a triple bond is nitrogen, okay? So if you see a compound and it has just single bonds, the energy that will be required to break it apart is going to be much less than a compound like here, which has 1.33 bond order, right? Because it's a little bit stronger than a single bond. The double bond is going to be even stronger, so like CO2 here, when I draw CO2, will be even harder to break apart. And then something like N2, which has triple bonds, we just can't. We've got to create, we ended up creating the Haber process in order to do that. It's a whole reaction we have to do in order to break up N2. It just doesn't happen in nature. We break up O2 all the time to produce ozone. O2 breaks on its own, okay? N2, we gotta actually, chemically, we gotta force it, but it goes against nature because the triple bond is so strong, okay? So, single, bond order of 1. If I have only double bonds, bond order is 2. If I only have triple bond, order of 3. If instead I'm mean and I give you an example like this, where I have a double bond and a single bond, you average to give 1.5. Or here, you average a single, a double. So it'd be 4 divided by 3 spots, so it'd be 1.33. I've thrown all of this information at you. Now I'm going to have you guys actually synthesize it and make sure it makes sense. But I do have to change one thing in your workbook before you do that. I'm looking, oh, it's under my apple. I'm looking for my workbook. A couple things I got to change. So turn to page 72. So there are a total of 9 compounds that you're going to work with for this worksheet, which is not bad. If you look at the top of page 72, I give you a list of 6 things you need to do. I'm going to add 2 more. Okay, so I need you to write a number 7. For number 7, determine bond order. Number 7, determine the bond order. We just went over that. You guys can totally do that now. Number 8, determine the bond angle. When you are ready, if you will turn to page 74. I need to change one thing here and then one more thing. For page 74, number 8, you make it C2H6. C2H6. And for number 8, you only have to do number 1 and number 2. You don't have to do the rest of those, right? Because C2H6 isn't going to have a central atom, so you can't do the other problems. So just 1 and 2 for number 8. Does that make sense? So you're just determining the number of valence electrons and drawing the structure. Okay. Last thing I'm going to change back on page 72. Number 3 for bromine. You do not need to do number 3 for bromine because again, there is no central atom. Number 3 for bromine, number 3, you do not have to do. Just put Na for number, not the whole problem, right? Does that make sense? You have to do 1 through 8 normally. Just number 3 you don't have to do. Are we okay?
Yeah.
You guys have right now, oh, you guys have more time than the other class did. I went faster. You guys have about 38 minutes right now, okay? This is homework. Your other piece of homework is going to be notes 8.3. There's very little on notes 8.3. It's just some conceptual stuff. I didn't even give you practice. Okay? For anyone who had asked for a signature for AP Chem or got a signature for AP Chem or intends to enroll in AP Chem, there is an additional assignment you need to print out and complete. Okay? So I'm just letting you know that, so you do have extra homework. Okay? Get working, work efficiently right now, and you should be able to get most of this done. Yeah, absolutely. Sure. Yep.